Hi, I'm Martin Bailey from Global Graphics Software. Today I'm going to talk about the speed and scalability of the Harlequin core, which is a raster image processor, or RIP. That's a tool for transforming a page description language, such as PostScript or PDF, into a raster that the electronics on an output device can understand. In other words, it's a key component for anyone building a digital front end, or DFE, for a digital press. Harlequin Core is specifically designed to be at the heart of DFEs built by vendors to drive their presses at blazing speeds, but without an excessive bill of materials. Many people don't realize the full impact on RIP requirements of switching from conventional print using offset, flexo, or screen printing, for instance, to digital, or of decisions around the design of next-generation digital presses. One of our OEM partners commented, "I didn't understand why Global Graphics kept talking about making Harlequin faster and faster until we started driving digital presses, and then it was obvious." The most common driver in many print sectors for switching from offset, flexo, or screen printing to digital is the ability to print shorter run lengths profitably. But that clearly has an impact on the load on the digital front end for the press, compared with the RIP for a plate setter. If I print 100,000 copies conventionally, it'll be on press for several hours, and I have all of that time to make plates for the next job. If I print 250 copies digitally, it'll only take a few minutes, or even seconds, and I will have to have the next job ready to print in that time. In other words, on the digital press, I only have a tiny fraction of the time to process each file that I would have had for a conventional press. And I don't want that press to be sitting idle waiting for the RIPs. Delays between jobs have an increasing impact on profitability as run lengths get shorter, because every minute waiting is a larger proportion of the total time for each job. And that's assuming that my customers won't use a significant amount of variable data, let alone print jobs where every page is different, often described as EPID. If every page or label or carton or whatever is being printed is different or has variable data on it, then at least some parts of every piece of output need to be processed through the DFE to do ripping, color management, halftone screening, and everything else required. So now I have even less time for every piece. I need to process everything fast enough to feed the digital press at full engine speed. For the very fastest presses, that may mean I have around 75 milliseconds for each A4 or US letter equivalent. Even at, say, 120 pages per minute, which is only 22 meters or 75 feet per minute for a typical narrow web label press, for instance, I only have half a second for each A4 or US letter equivalent. If I can't do that, then I'm going to have to slow my press and take the hit on my profitability. If you genuinely believe that your press will never, ever, ever be used for prints where every item is different, and that your customers will never, ever use a significant amount of variable data, you might as well stop watching now. But we worked with quite a few digital press vendors who were confident that their customers would not do that. Then mostly discovered that print service providers and converters and their buyers were more innovative than they expected. After all, the second major driver for adoption of digital presses is to print jobs that could not be done on a conventional press. And variable data is an obvious example of that. And you shouldn't just be thinking about headline-grabbing marketing campaigns like Share a Coke here. There are all sorts of opportunities in direct mail, general commercial, labels, packaging, decor, security, and specialty print, where variable data can be useful. And sometimes, even just a humble serial number or a QR code for a competition entry is all that people want to do. The bottom line here is that you need to understand the amount of data that a digital press requires, its data rate, if you're building a DFE for it. Different stages in data handling will need different data rates. If you ever move unscreened data around, that will need the biggest pipe, but it's also the best indicator of the load on the RIP. And then you need to work out how to integrate an appropriate number of RIP cores to generate that much data without inflating the bill of materials with the DFE hardware. Exactly how you calculate data rate tends to vary between sheet and roll-fed presses, and some marketing may be a bit short on details for product comparisons. But the basis is always, what resolution am I ripping to in both dimensions? Because we're essentially counting pixels here, and a higher resolution means more pixels. How many colorants am I ripping to? That's usually the same as the number of inks that are available on the press. More colorants means more raster data to be delivered. And what area of output am I printing per minute or per hour, including both sides for duplex printing? Again, a faster print speed increases the number of pixels to be delivered. We have a separate video and a data rate calculator available to learn more about the details of data rates. I'll include a link at the end of this presentation. Just to share a few examples to help fully understand why data rates are important though, here are some numbers for a few presses. I should point out that none of these are intended to exactly match presses that our OEM partners are driving, but each one is based on typical specifications. So the list includes a commercial press matching common V3 specifications, a label press typical of those being sold a year ago, a large, fast, wide format press printing in 8 colors, a B2 commercial press printing duplex at 1800 sheets per hour, a label press typical of those currently in development, a very large, very fast single-sided press for corrugated preprint or for decor. There are two obvious takeaways from these examples. Firstly, there's a huge range of data rate requirements depending on which sector and price bracket you're designing your press for. The horizontal axis used here is logarithmic, so you can see numbers more clearly. The fastest press is taking over 80 gigabytes per second, compared with the slowest taking less than half a gigabyte per second. Secondly, I'll focus on the two label presses. The slower one is typical of what vendors were selling in 2019 and 2020, while the fast one is closer to what many vendors are selling or launching in 2021. You can see that resolution, number of colorants, and substrate speed are rising for each new generation of press, and the effect on required RIP and DFE data rates can be very significant. In this case, data rate steps up by around 10 times. I kept the same logarithmic scale on this graph as on the previous page. And that's without taking any account of the background industry trends towards increasing graphical complexity of designs and increasing use of variable data. By the way, I picked label presses as an example here because we're seeing so many vendors making this jump at the moment. But the same discussion could be had about many other print sectors. The takeaway here is that a DFE designed for the older press is unlikely to be able to drive the new press for very short run lengths or for variable data printing. So how do you make sure that the DFE you're building can keep up with your first press or the next press that you're planning? The data rate that a DFE can support depends on 4 key factors. How fast and well optimized are the components, such as the RIP cores that you're building on? How efficient is the overall software architecture, especially for managing the huge amount of raster data between the RIP cores and the press interfaces? How much computing hardware do you use, and how fast is it? How efficiently constructed the PDF files you're processing are. I'll come back to that last one later. Let's just look at how the first 3 factors affect one of the key challenges in building a DFE. The speed of each component and the quality of the architecture both have an enormous impact on the requirements for hardware. And the speed and amount of computing hardware you use is the biggest influence on the capital cost of building a DFE. Using faster components in a better architecture can significantly reduce the overall bill of materials for building that DFE. So RIP speed matters in 3 steps, usually in this priority order. Increasing the proportion of jobs that can be ripped at full engine speed, decreasing the bill of materials for the DFE. A faster RIP means matching press speed with lower hardware costs, and being ready for the next generation press with higher resolution, wider, faster moving substrate, more colorants, more variable and unique jobs, without having to redesign the entire DFE architecture. All of which is why we've spent so much effort on optimizing and tuning the code in Harlequin Core to deliver maximum speed without compromising quality. Harlequin was one of the first RIPs to use symmetric multiprocessing 20 years ago, but then we completely rebuilt our multi-threading support and continue to tune it as hardware evolves for modern multi-core CPUs and multi-CPU servers, concentrating on the most effective areas to parallelize. And we've added the ability to render one page while interpreting the next to squeeze out even more time. Harlequin Core also includes Harlequin Varidata to optimize processing of variable data printing by rendering reused combinations of graphical elements as few times as possible. Unlike other vendors' VDP optimizations, Varidata can look beyond the hierarchy of graphical building blocks that the designer chose to use. It can also intelligently identify reused data in less well-structured PDF files. And it works both for PDF VT and for more general optimized PDF. These speed optimizations are valuable right across the spectrum of press data rates, from light digital production up to truly industrial scales. There are users regularly printing single PDF jobs containing millions of pages using Harlequin. And single huge pages for grand format, wall coverings, textiles and corrugated cartons, etc. can be automatically split into tiles and processed across multiple RIPs. Because, as you've seen, the fastest digital presses need tens of gigabytes per second of raster data, far more than any single RIP can deliver. That's why Harlequin Core includes a framework for efficiently splitting and load balancing jobs across multiple RIPs and, if required, across multiple servers, all with no need to split PDF files in advance. In other words, there's a full range of scalability from a single RIP through multiple RIPs on a single server to multiple RIPs across multiple servers, suitable for everything from light digital production all the way up to the fastest, largest press for corrugated.equal. Coming back to poorly prepared PDFs, most press or DFE vendors don't have much, if any, control over how PDF files are built, so you'll need to make sure that your DFE can handle reasonably inefficient files. But we can help you with that as well in two different ways, beyond, of course, making sure that Harlequin can process those files as quickly as possible. We've provided a lot of pointers for file creators in our guide, Full Speed Ahead, How to Make Variable Data PDF Files That Won't Slow Your Digital Press. I'll give you a link at the end of this presentation, and that link can also be shared with print service providers and converters, and with their customers, and the designers building work for them. Secondly, we have additional technology components that can be used in or with a DFE to streamline PDF files before submitting them to the RIPs. And if you need help with the system engineering around the RIP, especially for transporting rasters from the RIPs to the press interface, we can help with that as well. Building systems to marshal and transmit huge volumes of data at high speed is a fairly specialized skill. Just look for Direct on the Global Graphics website. And that website is at globalgraphics.com, where there's more information on Global Graphics Software's technology components for building DFEs, including Harlequin Core and Direct. If you have any questions or want to discuss our technologies further, please don't hesitate to drop me a line at info@globalgraphics.com. You can find the data rate calculator that I mentioned at blog.globalgraphics.com/data rate calculator, and the Full Speed Ahead guide is at globalgraphics.com/full speed ahead. And there are more videos on the Global Graphics TV channel on YouTube. They include one on the data rate calculator and more on Harlequin Core, our RIP technology designed and tuned to help you drive the very fastest digital presses. Thanks for listening. And I hope you found this interesting and useful.